How do you simplify complex fractions when you have a fraction over a fraction? Well, we know that we have a fraction on top, so a over b is our first fraction, and then c over d is our other fraction. The line between a and b and c and d is a division line. So what we can do is rewrite this as division and say that a over b divided by c over d. And now we've set it up like a regular division problem, which we know when we're dividing fractions, that we can change it to multiplication. So we keep the first fraction, change the sign, flip the second fraction. So we're going to use this same idea when we're simplifying rational functions. So if we look at this, same idea. This giant line here is your division line. So we're going to set it up as a division problem. X squared y over x plus 1 divided by 6xy squared over x plus 1. Since it's division, we're going to change it to multiplication. So we're going to keep the first fraction exactly the same. We're going to change our sign, and then we're going to flip our second fraction. From here, we're just going to multiply rationals. So if we can cross cancel anything, we're going to do that. So the x plus 1s are going to be gone. And now the 8 and the 6, I can divide them both by 2 and make this a 3 and make this a 4. With the x's, I can get rid of this x altogether and change this x squared to an x. And then I can get rid of this y and make this y squared into a y. So now on the top, I just have a 4x. And on the bottom, I have a 3y. What would the domain restrictions be? So again, since it's division, we're doing everything that is or once was a denominator. So if I take x plus 1 and set it to 0, x cannot equal negative 1. The 6xy squared was the original, was the new denominator. So I can take that x and set it to 0, and that's going to be a 0. But then I also have y, so y cannot equal 0 as well. Okay, so if we look at another one, again, set it up like division. And then once we have it set up as division, we can change it to multiplication by doing stay switch flip. Okay, so we're going to keep the 9m plus 6n over m squared n squared. And we're going to times by 5m squared, so we're flipping this fraction, 12m plus 8n. So now we can factor, so we can take out the 3, and we're left with 3m plus 2n. On the bottom, we have m squared n squared. The top is 5m squared still. The bottom, we can take out a 4, and we have 3m plus 2n. So from here, we can cross cancel. So the 3m plus 2n is going to be gone. And then I can get rid of this m squared and that m squared. So what I'm left with is 3 times 5 on the top, so 15. And on the bottom, I have 4n squared. And if I set these equal to 0, the m squared, n squared, both of them are going to just equal 0. So m can't be 0 and n can't be 0. The 5m squared, same thing, is going to be 0. And then if I have 3m plus 2n, 3m plus 2n equals 0, I want to solve it for m, and then I want to solve it for n. So if I solve it for m, I'm going to subtract the 2n. So 3m equals negative 2n, and then I'm going to divide by 3. So m cannot equal negative 2n over 3. And then when I solve the same thing for n, I'm going to get that n cannot equal negative 3m over 2. But what if there is addition or subtraction involved in one of the fractions? So in this, we have a messy bottom and a messy overall fraction. So first thing we want to do is focus on the bottom piece. So 1 as a whole is 1 over 1, and then we have x over y. So we're going to focus on the bottom right now. So I need a common denominator. So I need a y here and here. So I'm going to keep that 1 on the top just the way it is, and I'm going to change this to y plus x over y. Okay, because I have y over y plus x over y gives me y plus x over y. Now I can rewrite this as division. So I can say it's 1 divided by y plus x over y. So I'm going to keep change flip, and I'm going to rewrite the 1 as 1 over 1. So times y over, and you can either write it as y plus x or x plus y, whatever you feel like doing. And then here we're just going to multiply across. So we get y over y plus x. And that would be our final answer. Okay, x cannot equal y. And then y cannot equal 0 or x. So that's going off of all of the denominators. Okay, if we look at this one, so now we have addition going on in the top and the bottom. So we just want to focus on them separately. So I'm going to, again, rewrite 1 as 1 over 1. And this is 2 over x divided by 2 over 1 plus 3 over 2x. So let's just focus on the top first. So I need an x on the first fraction. So this is going to become x plus 2 over x. On the bottom, I need a 2x for the first fraction. So this is going to become 4x plus 3 over 2x. So now that, I'm just going to extend that line. So now the top is x plus 2 over x. The bottom is 4x plus 3 over 2x. So what I can do now is rewrite this as division. So x plus 2 over x divided by 4x plus 3 over 2x. So we're going to keep the first fraction. We're going to change our sign to multiplication, and then we're going to flip our second fraction. So now we can cross-cancel these x's out. So on the top, we have a 2 and an x plus 2. On the bottom, we have a 4x plus 3. So that's going to be our answer. And then our restrictions, x cannot equal 0, and also negative 3/4. So that's if you set 4x plus 3 equal to 0. And if we look at one more. So again, focus on the top and bottom separately. So I have 2 over x plus 4 plus 2 over 1. Okay, so we always want to make sure that we have a denominator under a whole number. So we'll just put 1 under there. And then 1 over 1 plus 3 over x plus 4. So if we focus on the top, in the top we need an x plus 4 on the second fraction. So what we're going to have on the top now is a 2 from the first fraction, and then we're going to distribute the 2 into the x plus 4. So that's going to give us 2x plus 8 over x plus 4. And then we have our division line. And now on the bottom, the first fraction needs the x plus 4. So x plus 4. So we're going to end up with x plus 4 plus 3 over x plus 4. So I'm just going to combine like terms on the top. So the 2 and the 8 can combine together. So what I really have now on the top is 2x plus 10 over x plus 4. And then I'm dividing. I'm going to combine the 4 and the 3 and get x plus 7 over x plus 4. So what we can do with this, keep change flip. So we're going to keep the 2x plus 10 over the x plus 4. We're going to multiply x plus 4 over x plus 7. So the x plus 4's can cancel. We can factor a 2 out of the 2x plus 10, but then we're left with x plus 5, which won't cancel. So we can just leave it as 2x plus 10 over x plus 7. If you want to factor out the 2 in the top and make it 2 times x plus 5 over x plus 7, that's fine too. And our restrictions, x cannot equal -4 or -7.